students, today's agenda is to check homework. We'll be graphing more parabolas and you will be able to do 11.5. If you haven't, I recommend that before watching this video, you watch 11.4. Today's students will be able to complete the square to graph parabolas. Let's begin by doing a warm-up. It says sketch and analyze the transformation. And so for number one, we're just going to add x squared to both sides so that we can isolate y. And so you will have y is equals to x squared. And if you notice from the previous lesson, we can see that that's just the mother graph of a parabola, right? So when it's x squared, it's just 0 times 0 is 0. The value for y is, if x is 1, 1 times 1, that's 1. If it's 2, 2 times 2 will give me 4 for y. And on the other side, negative 1 times negative 1 is positive 1, and negative 2 times negative 2 is positive 4. Okay, and if you did more, then you would get the 9 for the 3 times 3. So that's my mother graph for the parabola. So the other ones, we're just going to analyze what's going on in here. And remember that if it's in terms of y, then inside of the parentheses, we're going to go opposite on whatever is being added or subtracted on x. So if it's adding 3, in reality is going to go to the negatives, okay? And for y, we respect that because that's exactly what it is. So y is negative 3, so for that one, we do go down. It's only inside of the parentheses, it goes opposite direction on that axis. So in here, if we have our mother graph from this one right here, it would be like that. That's the mother graph, but then you're going to go 3 spaces to the left and 3 spaces down. And so the vertex goes 1, 2, 3, and then 1, 2, 3 right there. And you can do the same thing for all the other points, or you can just say, oh, this one is 1, 1 and negative 1, 1. So you just go 1, 1 and negative 1, 1. Okay, you're just plotting those points just on each side of that. And then for this point, it was 2 spaces and then 4. So the same thing from the vertex, 2 spaces and 4 right there, 2 spaces and 4 right there. So that's just sketching without plotting points. Now it's just doing the transformation, okay? Okay, for number 3, again, our mother graph would be 2, 4, and then negative 2, 4 right there. And what are we doing now? Oh, it's subtracting 3 on x, then it's going to go to the right. Remember, inside of the parentheses, it goes opposite on whatever is in there. And so for y, will go up. That one does respect that y is positive 3. Okay, having that in mind, we're going to go, and you can do either one, you're going to end up with the same point. You can do the y transformation first, so 1, 2, 3, and then 3 to the right. 1, 2, 3, right there is going to be my vertex. If you decided to do this one first, you just go 1, 2, 3, and then up 1, 2, 3, you still end up in there. Again, we have the 1 and 1, 1, 1, and then 1, 2, 1, 2, 3, 4, and 1, 2, 1, 2, 3, 4 right there. And that's my transformed parabola. For number 4, we don't have the mother graph, but we saw it in the previous lesson. And so y equals y squared, it just means that you're going to give now values to y. So if y is 0, then x will be 0 times 0 is 0. And then for the next point, if y is 1, 1 times 1 is positive 1 for x, but if y is also negative 1, negative 1 times negative 1 is positive 1. If y is 2, 2 times 2 is 4 for x, so the x is 4 and the y is 2. And if y is negative 2, negative 2 times negative 2 is positive 4, so the value for x is going to be positive 4. Again, if you need to reaffirm that, you can just go ahead and watch 11.4 first. So that's our mother graph for this one, right? So the transformation, remember that whatever is outside of the parentheses is respected and it's moved the way it says in there, but in regards to the isolated variable. In this case, it's going to go on x to the left. When it's outside of the parentheses, you just follow the sign. When it's inside of the parentheses, then you do the opposite. In this case, it's only for x, one space to the left. So right there, and it's only one space, minus 1, right there, this 2, and this one as well. And so that's our new transformed graph. And so before we continue, just a reminder that when x is isolated and y is squared, then the parabola will hug the x-axis. But when you have the y isolated, then and the x is squared, then that's when the parabola hugs the y-axis. Okay, and now for the lesson of the day, which is to complete the square so that we can set it up as we sign the warm-up so that we can easily graph our parabolas. So in here, the first thing that I'm going to ask you to do is to leave a space. So y is equals to x squared plus 6x, leave a space and put the 4, and then you're going to put another space in here. And the reason is because we don't want to change what we have in here. Nothing is going to be added to the other side, so we don't do that in here. So we're going to add 0. And the easy way to figure out what number I'm going to add in here is to divide this by 2 and then square that, because that's going to give us the square, the perfect square as we saw in the previous lesson. Okay, so we're going to have x in here. 6 divided by 2 is 3. We raise that to the second power, and 3 times 3 is positive 9. However, we don't want to change this, so if we add 9, we'll also include negative 9. And by adding 9 and negative 9, it's like we're not adding anything, okay? So that gives us y equals, these dimensions of the perfect square come from this part right here, okay? So x plus 3 is the same as x squared plus 6x plus 9. So that leaves us with having to simplify that, which is positive 4 and negative 9 is negative 5. So now we completed the square. This is a perfect square because this is the dimensions of x plus 3 times x plus 3. And x times x is x squared. 3 times x is 3x. 3 times x is 3x. And 3 times 3 is 9. So that's this right here. This area is this. And this is just x plus 3 to the second power because it's x plus 3 times x plus 3. And at first, some people might say, oh, but where is that? I only have 4 and negative 9 is negative 5, but they think that they have to add this to this. No, this is included in here already, okay? It's right there. Okay, now we have it all set up to graph. Remember that for the mother graph of y equals x squared, it's 1, 1, negative 1, 1, 2, 4, negative 2, 4. And so now we're just doing that transformation. If you remember, inside of a parenthesis, we do the opposite and to that. Okay, so we're going to be subtracting 3, or actually going left 3 spaces. For y, you just follow what it is. This is -5 for y, and so each point is going to do that, which is 3 spaces to the left and 5 down right there. And from there, you just remember that it's 1, 1, -1, 1. So we're going to do the same thing here. And then 2, 4, and 2, 4, 2 on the other side. And that's our new transformed graph, which we can graph from completing the square. Okay, let's do another one. Okay, for number 2, we're going to first, we notice that we have everything in here, but now we have values for y. So x is only 1. We're going to cancel the x. This cancels and you get x equals, and you bring down the other 3 terms. Okay, so now what I'm going to do is, and at the end we're going to switch this x equals to that, but let's complete the square for the y squared plus 2y minus 2. So remember, let me put the x over here because it's just like switching them. And I'm going to put y squared plus 2y. We're going to leave a space, then -2, and leave a space. Again, we're going to complete the square in here so that we are able to factor it to a perfect square. But we're going to do that by adding and subtracting the same amount. It's just like adding 0, okay? Okay, how do we find what we're going to add? We just put the square for the dimensions y, and then we're going to divide this by 2. That's how we find that number, and that one raised to the second power gives me this value. So 2 divided by 2 is +1. We raise that to the second power, and +1 times +1 is +1. But if we add 1, we also have to subtract it because we're just adding 0. Remember, 1 positive and 1 negative becomes 0, so we're just adding nothing, basically. We're not changing that original equation. And so, again, this perfect square comes from this, from completing that square. And so now we're just left with simplifying that part. -2 and -1 becomes -3. And bring down our x. So again, if x is isolated, that means that our values are hugging, right, the x-axis. Okay, our parabola is hugging the x-axis. 2, 4, -2, 4. Okay, so that's our mother graph. Those are the points for the mother graph. Now let's do the transformation. Inside of the parentheses, this goes opposite on that variable. So that means that it's not going to go up on y, it's going to go down 1 space on y. And this one is on regards to this variable. So -3 is going to be to the left on x. Okay, if it's outside of the parentheses, we keep that sign. If it's inside of the parentheses, we change it on that variable. Okay, so this vertex is going to go 1 space down and 3 to the left. 1, 2, 3, right there. And then from there, we go 1, 1, 1, 1. So right there. And 2, 4 is right there. And 2, 4 is right there. So that's our transformed graph of the parabola after we completed the square. Okay, number 3. Again, we're going to get rid of the x plus x plus x. This cancels, and I'm just going to switch it since you saw that we can just switch them over here. 0 plus x is x. I'm going to put it over here already. And then right here, I can just put y squared minus 6y and leave that space, plus 16, and then leave another space. Okay, the only difference is that I changed this and I already left the 2 spaces for us to complete the square. Okay, so we're going to have x equals, we open our parentheses. Remember that in here we're going to create our perfect square, right? That's not a perfect square right now. So we put y. To find the perfect square, we divide by 2. Negative 6 divided by 2 is negative 3. Now we're going to square that, and negative 3 times negative 3 becomes positive 9. But if we're adding 9, we also need to subtract it so that we don't add anything. We're just adding 0 again. Okay, now we simplify this part. And 16 minus 9 gives us positive 7. Again, what does this tell me? If it's inside of the parentheses, it will go opposite on that variable. So negative 3 is going to be positive on y, meaning going up. And for this one, we keep the sign, positive 7 on that variable. Okay, so that's how they're connected. That means that it's going to be positive 7 on x, that's to the right. So now that we have, again, our mother graph would have been here, and then 2, 4, and negative 2, 4. Now we go 3 spaces up for the vertex and 7 to the right. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 right there. Then we have 1 and 1. Then 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. I'm just going off the vertex and then counting how many spaces it goes for the next point, okay? And so that's my graph now that I have completed the square. That's it for our lesson. If you can please give us a thumbs up, subscribe around here. Here is the playlist for this entire unit, and you will find the next video here. Now you're able to do 11.5, but don't forget, have fun.